Hey, welcome back to Math with Patrick. It's April 5th, and we have problem number 95 to solve from this Daily Epsilon calendar. And the answer is 5, so we know that if you plug in a 5 right here, this equation will be true. But we should prove why this is the case, and also hopefully prove why there are no other solutions that might make this equation true. So let's start. I see a square root of some number squared plus 24. And then finally, when I do all of that math, I subtract a 2, and I get right back to where I started. So let's try to solve for x. I want to get rid of that square root sign because that gets a little funky. And I also want to get the x's on the same side of the equation. That way I don't have to think about my input as also being my output. That's kind of weird. So to get rid of a square root sign, the best thing to do probably is square it. That's like the opposite operation. So like for example, if I have like the square root of 3 and then I square it, that'll just get me back to 3. And I could square this side and then square that side. Like that's a valid step. But then when I do this multiplication, I think I'm still going to get more square roots in that left expression. And so my first step is going to be adding a 2 to both sides of my equation here. So this equation that I have is different, but the equality is the same. I know that these two things are still equal. I know that I'm allowed to add 2 to both sides of an equation, and it's still going to be equal to each other. Now is a great time, I think, to square it. So like I said, the opposite of square rooting is just squaring, and those two operations should cancel out with each other. And as long as I square the right side of my equation, this should still be true. Now, some funky stuff does happen with square roots, so I might get 2 answers for this problem, but it's always really useful to go back and plug them in and see if that funky stuff does happen or not. So we'll see. I have a quadratic equation here. I have like x squared. There's going to be like an x squared coming out of the right side as well. And I want to set this into standard form, or basically just set everything equal to 0, because that's my preferred starting point when solving quadratic equations. So let's keep the left side the same, and then let's expand the right side. Here I'm just doing some binomial multiplication. Oh, and I guess my x squareds go away, because I could think about maybe subtracting an x squared and subtracting a 4 from both sides. And then x squared minus x squared is 0, 24 minus 4 is 20, and then it looks like I'm just left with a 4x. So this is just a one-step equation. 4 times something is 20. Well, that something has to be 5. So there it is. The algebra shows that there is one and only one solution, and let's just plug it in just to be sure. So it looks like if I square root 5 squared and then add 24 and then subtract 2, I should get that 5 over here. And let's see if that's the case. 5 squared is 25, and then 25 plus 24 is 49. And then 49, the square root of 49 is 7. That's because if you work backwards and do 7 times 7, you get back to 49. And at this point, it is abundantly clear to me that yes, indeed, 7 minus 2 is 5. And that confirms my result from earlier that yes, x should be 5 today. And it seems like there's no other solution. It's 5 and only 5. So that's it for today. Thanks for coming along, and I'll see you in the next video. Bye.